Hello everyone, this is SUDHA.C. I'm here to present my video animation lecture about the topic magnetically coupled circuits. I chose the subtopic mutual inductance. We will see what is mutual inductance, how it works, etc. First of all, we know that inductor generates an induced EMF within itself as a result of changing magnetic field around its own turns. But here, mutual inductance is the interaction of one coil magnetic field and another coil as it induced the voltage in adjacent coil. Now, if you connect an inductor to AC mains, current will flow through it and it produces a magnetic field around and inside of the coil. If we then place a second coil in close to each first coil, pass the alternating current through first coil, the magnetic flux it creates will induce a current into the second coil. And this magnetic force will push and pull on the free electron, forcing them to move. The key component here is that the magnetic field is changing polarity as well as intensity. This change in intensity and direction of the magnetic field constantly disturbs the free electron in a secondary coil, and this forces to move. This movement is known as electromotive force or EMF. And electromotive force does not occur when we pass DC current through the primary coil, and the magnetic field is constant, so electrons are not being forced to move. And mutual inductance depends on various factors including number of turns in secondary coil, cross-sectional area, closeness of two coils. Next, the subtopic is transformer. A transformer is made of several different parts that function in their own different ways to enhance the overall functioning of a transformer. These includes core, windings, insulating oil, etc. As shown, the figure has primary and secondary windings. The core lamination are joined into the forms of strips. In between the strips, you can see that there are some narrow gaps are said to be imbricated. Both the coils have high mutual inductance. Most of the alternating flux developed by the coil is linked with the other coil and this produces the mutual induced EMF. And next, working principle. It operates on Faraday's principle of mutual induction. So, it produces EMF can be explained by Faraday's law of electromagnetic induction. Then we go to the types of transformers. Instrument transformer, step up and step down transformer, single phase, three phase transformer, power and distribution transformer. Next, we will see power. The value of a power for an electric circuit is the value of a voltage by the value of current intensity. As in the case of a transformer, the value of the power in the primary is the same value of the power in the secondary. We have that represent VPIP is equal to VSIS. P suffix means primary, S represent secondary. These are the simple equations related to transformer. The value of the power for an electric circuit in the value of the voltage by the value of the current intensity. And Vp divided by Vs is equal to Np divided by Ns. P represents voltage, N represents number of turns in the coil. Here, increases the voltage from primary to secondary is called step-up transformer. As step down is converts high voltage low current power into low voltage high current. This is the waveform of step down transformer. Here the input voltage is high and output current is high. I hope this lecture is simple and clear. Thank you.